Hello guys, I'm Engineer Abdullah. Here we go again. Today I'm gonna explain one of the most important topics in mathematics is logarithmic function. What's the logarithmic functions? Logarithmic functions is log with a base b of x, where logarithmic function is the inverse. It's a logarithmic function. It means what's the power of b give you the value of x. It means again what's the value of the power f of x with the base b equal the value of x. For example, f of x equals 0, b with power 0 equal 1. Any number with power 0 equal 1. Without 0 power 0, it's indefinite value. As you see, b, it's impossible equal 0 because 0 power 0, it's indefinite value. For example, if x is smaller than 1, as the value of x approaching to 0, as the value of x is approaching to 0, the logarithmic approach to minus infinity. As you see here, b is the base, and f of x is minus infinity. Minus infinity, it means 1 divided by b to power f of x, absolute value f of x. So, as limit of x approach to 0, it's the power gonna approach to minus infinity. So f of x is smaller than 0. As the x is smaller than 1, f of x is smaller than 0. It means f of x in minus values. As you see, where b is known as base, and its values usually, not always, between 0 and 10. It's impossible to be 0, as I said. If b is equal e, as you know, e it approximately equal 2.71. Approximately. This number is not exact number. So f of x equal log with base e of x is equal len.
Euler.
This e is known as Euler number, or according to the Swiss scientist who's invented, who's invented the series equals number e. I will discuss this in next lectures. If b is equal 10, f of x equal log with base 10 of x. So, you know, x, it's impossible to be 0 or negative number because there is no power, it's impossible to find power and number power negative or positive give you this value in negative. As I said, b is impossible to be negative. It's always positive from 0 to 10 usually. So the x is always positive from 0 to infinity. X from 0 to infinity. Let's discuss this graph. This graph is really important in today's lecture. For example, I have y equal log with base 10 of x. As the base is increasing, this idea is really important. As the base is increasing, this function gonna push to x-axis. As you see, it's gonna push to x-axis. And from here, yellow function gonna push to x-axis. Because small, I will discuss what's the cause for this graph. Because a small variation in y, small variation in y will cause a high variation in x, as you see, high variation in x, according to this equation. B power f of x, if b is bigger, is the most number, then small change in f of x, y, it causes a high change in x. And as the base is smaller, 2 here is the smaller, the function is gonna go far from x-axis, as you see. It's gonna go far from x-axis on this one. So let's see another idea we'll discuss. Sometimes we have this kind of logarithmic function, f of x equal logarithmic, and inside the logarithm not x, g of x function, we should find the values of x which makes g of x larger than 0. Because impossible to find the value of x to find the value for this function when g of x equal 0, as I said, because there is no logarithmic for negative values. There is no logarithmic for negative values, so we need to find g of x larger than 0. First example we'll discuss, f of x equal log x squared minus 4. We need to find the values of x which makes this function inside logarithmic larger than 0. We need to solve this equation, x smaller than minus 2 and x larger than 2. So the domain and range of this function is minus infinity to minus 2. It's impossible to be equal to minus 2 because minus 2 square 4 minus 4 0. There is no logarithm for 0 number. So minus 2 intersected with 2 until infinity. So, and the range is minus infinity to infinity, as I discussed above. To make sure I'm solving this equation correct, let's see GeoGebra. I have first function is log with base 10 is the blue one here. Second one is log with base 2 is the red one, and the third one is len of x. It means log with Euler number, with base Euler number 2.71. As you see here, as base is increasing, the function is approaching to x-axis. Let's find this function, guys. Let's see this function. For example, f of x equal log 10 x squared minus 4. As you see, the range is minus infinity to infinity, and the domain so the domain is minus infinity to minus 2 intersected with 2 to infinity. As you see, the graph right here, the domain is from minus infinity here, pushing to minus 2, but will never ever arrive. It arrives to minus 2. It approaching, just it's approaching to minus 2. And here it's approaching to 2. And it goes to minus infinity, and here to minus infinity from 2, as you see. Thank you guys. Don't forget to subscribe and put a like to my function. Goodbye.